Okay, lesson 10, high availability for connections and applications. And this lesson is quite a long lesson, so I will split this lesson into two pieces. The first part of this lesson is a kind of a review from lesson 9. So many of the topics we already learned, so I will actually revisit same topic as a part of a review. And the second part is a new topic. So we will discuss application continuity and transaction guard topic. And as you can see, these are some of the topics already covered. Client-side connection time load balancing, and client-side connection time failover, and server-side connection time load balancing, and TEF. So I briefly covered these topics through class note and also through slide note as well. And the second part of this lesson is application continuity and also transaction guard topic. So here are the types of workload distribution, and what is client-side connection time load balancing, what is client-side connection time failover, what is server-side connection time load balancing, and what is runtime load balancing. So basically, I covered this topic like this. So in lesson 9, I started with connection time server-side load balancing. So we had two possible goals. One is long, and the other one is short. So short is service time load balancing, and long was connection time the number of connection-based load balancing. So that's what we discussed. And also a common usage of a long as a connection time load balancing goal is a multi-tier environment. So the time when you start in a connection pool, we evenly distribute connections because all three servers equally loaded. That's why we used a long-based connection time load balancing. We also learned runtime server-side load balancing as well. Over the time, we have a different the workload pattern and a different pattern of a workload across three instances running out of three servers. So in order to adjust connections to the instances, we leverage a fan message, and fan messages deliver runtime load balancing information. So as a part of a connection, the fast connection failover, we can adjust connections to least loaded instance more, disconnecting connection from heavily loaded instance. So that's what we learned. So let's come back here. Okay. Okay, so client-side connection time load balancing. So that's what we already discussed. So this is the old style. So you can use node VIPs the prior to 11.2. From 11.2, we replace node VIP with scan, single client access name. So that's what we learned. And also load balancing is done through scan VIPs. So you can define scan and scan VIPs in the DNS, or you can define scan and scan VIPs in the GNS. So by using DNS and GNS, it's possible to support client-side connection time load balancing. And FAN. The FAN is a fast application notification. In the clustered environment, if something goes bad, for example, service failed, or instance crashed, or you have a node failure, then Oracle Clusterware can detect this problem and describe this problem through FAN message, fast application notification, and then notify application to share these changes. The reason why we use a FAN in the clustered environment, so by doing so, application take action as quickly as possible. Otherwise, application wait for TCP timeout, so it will take a longer time until it realizes the problem in the cluster side. And Oracle client drivers and Oracle connection pools respond to fan event and take immediate action. So action is fast connection failover. And also there are other the examples of actions as well. Oracle connection pools use a fan to quickly detect failures and balance connections following failures and balance connections after failed components are repaired. And using fan event, it eliminates application waiting on TCP timeout and time wasted processing the last result at the client after a failure has occurred. So the fan message, it is to provide the cluster level status changes with the application as quickly as possible. And benefit is very clear. So application doesn't have to wait for the TCP timeout. And fan also can deliver runtime load balancing information as well. In the previous page, we saw that fan message can include high availability information. So this is to share with the application as quickly as possible through fan mechanism. In addition, we also can use a fan to share runtime load balancing information as well. Okay. If an application is a fan-aware application, like an Oracle connection pool, or Oracle WebLogic Server Active Link, Grid Link for Oracle RAC, then by consuming fan message, Oracle connection pools or fan-aware applications can take action immediately. And here we have a fan integrated client that includes a UCP, and this includes a .NET connection pool, WebLogic Server Active Grid Link for RAC, OCI, and ODP.NET. But if your applications are not integrated with a fan, then your developers must develop exception handler to consume fan message. And this is a fan and Oracle integrated client. CRS generate an HA event, and this message can be forwarded to all these clients through ONS, through advanced queue. And same message can be consumed by internal component. So by going through call out script. So if a fan message populated, an internal component can process this message to take action. And here are the fan-supported event types: service pre-connect. So you probably remember pre-connect method. It's a part of a TEF. And also service member and database related the fan message, and also service metric based. And fan message also includes a region code as well, and region. So user means user changes the status of a component. And failure, or because of a dependency, the component status got changed. And unknown means we don't know why status got changed. And auto restart, and also the public node down. So we have different the public network is down. So we have different regions. And also fan event also include the status information as well. So a component is up, a component is down, and also shadow application service comes up and comes down, and also node down and unknown and not restarting. So this is an example. So fan event message format look like this: event type, version, service name, database name, status, region, cardinality, and timestamp. So here are the two examples. The second example is service related message. So service name, the erp.example.com, this service was up in this timestamp. What was the region? Region was user started this service. Okay? And then we have a node-related fan event. The message describes node status change. Node, which named hoster 1, it was down at this timestamp. So we have this fan message. And also, the fan message can include runtime load balancing information. So that includes the version, event type, which service running on which database, at which timestamp, from which instance, how much the work can be done. And we have also status and flag of service. Okay, so once fan is generated, we can also consume this fan message in the cluster level by using callout script. So you can write callout script to parse the input information, which is a fan message, and also we can filter fan event, and we can also take action by using callout script. And this is an example. So in this example, we enter the fan event, and the fan event include the version, service information, and through timestamp. So just parse your fan message and fan event message, and then compare with this filter condition. If a fan event is about the HQ prod database or ERP service related, and these components are not restarting or restart failed. If conditions are met, then take action. In this case, open ticket. Okay, so we can actually create callout script to manage fan event in the Oracle cluster level. And also, in order to the notify application, we configure ONS, Oracle Notification Service. So through ONS port, message can be transferred. So in this case, we have a local port 6100, remote port 6200. So this is the port that will be used by server-side ONS between or among the members of a cluster. And also, ONS also can communicate with OMS running on mid-tier environment. So you will also have to configure a local port and remote port, and you will have to start. And this slide is giving you an example of a JDBC fast connection failover. Okay, so you have a UCP, Universal Connection Pool, and this is an Oracle Connection Pool. It can manage fan message, and also it can take action once fan message is delivered. So what happened is, in this side, we have a multi-node cluster. At some point, if a service is down and node is down, then UCP automatically identify invalid connections and clean up. That is a fast connection failover. Okay, so we have an invalid connection to node and instance, clean up those connections. That's the meaning. And also, another message, if another message is delivered, so service now came back, then UCP will take action. Okay, now we can reestablish connection. So fan message is the message the delivery mechanism. So a fast application notification mechanism. Okay, now by consuming this message, we should be able to take action. So that is fast connection failover in this example. And what is the benefit of JDBC and .NET fast connection failover? Okay, so if the component status changes behind the scene without having to wait for TCP timeout, application can clean up invalid connections and reestablish connection to the existing instances. So it can support connection from a new request. And also, we can take advantage of a fan, and fan delivers runtime load balancing information as well. So we use a fan that delivers runtime load balancing to redistribute connections, okay, to support load balancing at runtime. And once fan message is delivered to the application tier, load balancer advisory, and this will send the work across the rack instances based on runtime resource availability. And load balancer advisory advice is available to all applications that send work, JDBC and OODP connection pool, and connection load balancing as well. It relies on service goodness. So which service running on which instance can perform better, and adjust distribution based on runtime load balancing, and then stop sending work to slow and hung and failed node. So once load balancer advisory receive a fan message that includes the load balance information, it can take action. And this is an example. Over the time, we received a fan message like this. So instance 1 can perform 10% of the work. Instance 2 can perform 60% of the work for service. And instance 3 can perform 30% of the work. So we know that instance 2 is the least loaded instance. So we can redistribute connection. So we can make more connections to instance 2 because instance 2 can do more work. To do so, we need the connection rebalancing. That's a faster connection failover. And connection load balancing. So we have a long-based load balancing. That's what I explained. And short-based load balancing. And this is a connection time-based. And this is an example of a runtime load balancing message. At 4:19:46, instance 1 and instance 2 equally loaded. So instance 1, instance 2 can perform the 50% of a service work, and the other instance, another 50% of a service work. But as time goes on, we added more load to one of the instances. So instance 2 now can do 80% of the work. In instance 1, it can perform 20% of the work because we loaded more work to instance 1. So at this point, instance 2 can accept more work based on this. And also, we have a transparent application failover. So let's come back here. So we had a discussion of transparent application failover. That's what we learned. So there are two possible configurations. One is a basic, one is a pre-connect. Okay? With the basic configuration, so you will see this observation. The client initially connects to one of the instances based on service location. Okay? And suppose that this session issued a SQL statement. As a part of this submitting SQL statement, Oracle does perform parsing operation and also execution and also fetching. Actually, execution is only for DML, but I just added. So in this case, let's say from instance 1, we did a parse. So we parsed the SQL statement, and then we started the fetching data. So we fetched 90% of the data. Okay, only 10% of the data fetching is remaining. At this time, we have an instance failure here. That means you will lose this connection, and your select statement will be aborted. If a TAF is enabled, we can actually failover session to new instance. And also, if you enable the select statement failover, in the new location, you will have to reparse, and then you fetch only remaining data. So from client point of view, client will see the short the pending result and then resume. So that's what you're gonna see. So when you enable session and select statement failover, it's possible to failover SQL statement as well. And also pre-connect, we have same observation. and TAF basic and TAF pre-connect for OCI and for the Oracle Net Service connection can leverage TAF and also basic and pre-connect the method. This is an example of a TAF basic configuration on the server side. By creating, when you create service, you can enable TAF, in this case, basic mode, basic method. And you can also failover select statement. And this includes a session failover as well. In the old version, we had to add a TAF configuration in the client side. So that was too much work. So suppose that you have 1,000 clients. Then you have to update the client net configuration files across 1,000 client machines. So that was too much work. If you have a small change, you had to update all 1,000 client machines. But now we can configure TAF in the server side using SRv-CTL. It's a lot easier to manage. And finally, you will see that your connection, and we made a connection through service where TAF is enabled. In the client side, you can also configure TAF as well. So this is an old method. But we still need a client-side configuration if you are using pre-connect method. Okay? So you add a service and you enable pre-connect TAF policy. To support pre-connect TAF policy, you will also have to update tnsnames.ora or network configuration file to add primary connection and backup connection the information. So in addition to server-side configuration, you also need a client-side configuration. And you can also verify TAF configuration from $V session, and you will see which service was used to make connection. And you will also see whether TAF has been enabled at the service level or not. In the second node, and also we have the same information. And FAN connection pool and TAF considerations. And both techniques are integrated with the service and provide a service connection load balancing. And connection pools that use a FAN are always pre-connected. And TAF may rely on operating system timeout to detect failure. FAN never rely on OS timeout to detect failures. So FAN, it's used the FAN connection pool, which means that fast connection failover, it takes action after consuming FAN message immediately. So we can detect failure as quickly as possible, and we can also take action. But TAF, its benefit is it can fail over session, not the connection. Now, with a fast connection failover, if something goes wrong, the invalid connections will be cleaned up, and your existing session, all existing connections will be disconnected. And only for new connection request, we can serve through new established connections. But TAF, it can support session failover and also connection failover as well. Okay? Actually, select statement failover. Now, if it's possible to combine these two features together, so I want to failover session and select statement in the multi-tier environment through JDBC, and also I want to take immediate action in case of the failure in the clustered environment, then you will get full benefit. So I want to also the failover TML, even for the TML. So I had a session to instance 1. I executed, I submitted a TML statement. My TML was in progress. At this time, you have a instance failure. Then, I'd like to fail over session, not connection. And also, I'd like to replay or fail over TML in addition to select statement as well. So are there any other features like this? Yes, absolutely. We do have application continuity that provide all these combined features. So in session 1, in part 1 of this lesson, I briefly introduced some of the features of the services, like a service level, service time, server-side load balancing, and also client-side load balancing, and runtime load balancing, and we reviewed those topics. And also, we reviewed the fan message, and also fast connection failover as a result of a HA fan event, and also the runtime load balancing delivery. And that's what we learned. And we also learned the TEF. In part 2, we're going to get into the transaction guard and also application continuity. And you will see enhanced features that were introduced in 12.1, and we have also extended the features in 12.2. So I will cover this topic in the second part of this lesson. And this was the first part of lesson 10.